Hello my dear students, how are you all? Welcome back to the channel. Today I'm starting with the very beautiful chapter, one of the most important topics in calculus in your entire preparation of PU2, which is integration. Important not because it is just high weightage, because it is difficult for students. Okay, many of you in my previous year as well, like your seniors, did find this chapter challenging, but that's all right. Okay, that's why I'm here. If it was very easy, then why will you come to my session and watch my video? Okay, it's difficult. I'm here to explain you in the simplest way possible. For that I've taken a lot of questions. Okay, so today I'm going to cover up some topics. It is going to be integral part 1. So okay, we'll have indefinite integral to cover up today. We'll do it by some parts, and of course we have MOI. What is MOI? MOI is method of integrations. We'll also cover up the first method, which is nothing but substitution method, and we'll see some particular functions also. I'll repeat myself. We'll start with indefinite integral. This is all there, that only, right? Then we'll, in the MOI, in the method of integration, we'll do substitution method. Okay, and of course we also deal with some particular functions, and not to forget, I will solve questions on each of these topics and also give you some homeworks. Okay, from here on I want your answers very seriously, because these are difficult chapters. If you're getting stuck in it, I want to know which part you got stuck in. Okay, so let's start. Let's look at the session outline today, what we have. So total of I think first thing first, we're gonna practice. We will practice total of 24 questions. Okay, total of 24 questions. I think 22 to 24 questions I have taken today to solve in the session itself. And of course you see the topic, right? The topics are indefinite integrals, indefinite. Okay, then we move on to MOI. In MOI we'll learn only one topic today. Then there are various methods of integration. We're gonna learn the first method, which is substitution method. First method, which is substitution method. Okay, and we'll also see some of the particular functions, which is part of a syllabus. I've taken all this, which is part of your syllabus for both PU2 and KCET. Okay, so let's start. The first thing first. So actually the easiest way to understand integration will be just opposite of derivative. Okay, just the inverse process of derivative is called as your integrals. Got it? So means what you used to do in derivative, we had certain formulas, sir. The function was given to us. Remember, the function was given to us, and then we are finding the derivative of that, right? For example, derivative of the function gx is nothing but function fx. I can take different type of functions for gx. I can take logarithmic function, I can take trigonometric function, I can take inverse trigonometric function, and for all those functions I've given you formulas how to find the derivative. So we can reach from this function gx to fx using what? Using derivative. Great. Whenever you have something like this defined, then what happens is simply integrate the function fx. Integrate the function fx to reach back to the function gx. Please check. Simply integral of the function fx with respect to the variable x, will give you your function gx. Now there's something called as c over here. What is c called as? This is the constant of integration. Because integral of any function is not unique in nature. The integral of any given function, right, of any function is not unique in nature. Okay, so based upon this c value, if this c is 1, the function is different. If this c is 2, the function is different. So based upon the c value, the function will keep changing. So that's why the integral result is never unique. In which case, in the case of indefinite integral, this is in the case of indefinite integrals. Okay, when you go to the category of definite integral, where you have limits defined, then this becomes a unique answer. For a given set of limits, the function's integral will be always fixed. That is the case of definite integral. That will come later in the sessions. Right now we are dealing with what? We are dealing with only indefinite integrals. Okay, so this is clear. The first slide is very simple. What is integration? Just inverse, just opposite of your derivatives. Great, superb. Let's move on then. Now we'll see. Remember, I've given you a list of formulas for all the different functions. For the derivatives, same way I'm going to do what? Integrations as well, right? Starting with the first one. What is the first one? Polynomial function. Superb. If you have a function defined like this, x power n, I'm looking for integration of this, right? Now, whenever I'm, remember, if I have to differentiate a function, I was writing like this: d dx of something. In this case, when you're integrating it, you'll have dx over here. You'll have dx over here. So integral, how do we read this? There's a way to read this, okay? The way is integral of x power n with respect to the variable x. I'll repeat myself. Integral of x power n with respect to the variable x. Okay, let me erase this part. All right, sir. Simple things. I know it's a simple thing only, but as we move on to the session, we'll see the difficulty level increasing. What is the answer for this? Simply x power n plus 1 divided by n plus 1, and of course there will be a constant of integration as plus c. Is that clear? Yeah. So this is the integration of any polynomial function. Let's say if you have a constant over here a, I'll simply keep it outside and write it over here. If there is a constant, just keep it outside, okay? Same as the derivatives that we used to do. Remember, we used to keep the constant outside in the case of derivative also. Okay, a x power n dx is nothing but a times of x power n plus 1 divided by n plus 1. Integration, you're gonna go plus 1. Derivative was n minus 1. Remember? Yes. So next, what we're gonna do? One of the most popular derivatives. So we have 1 by x dx. Answer is given by ln x plus c. ln x plus c. Okay. Now we also have e power x integration. This does not change, right? E power x derivative is what? If you are not sure about this, start differentiating from this side. Derivative of ln x, what is that? Simply 1 by x. What about c? C is a constant. Derivative will become 0. Yes, same over here. If you do differentiate the right hand side, you'll get the left hand side. Okay, superb. Question number 4 now. Sorry, formula number 4. If you have a power x dx, answer is a power x divided by ln a. A power x divided by ln a. Of course, you'll have a plus c as the constant of integration. Okay. Next will be, remember the trigonometric functions. Integral of cos x. Answer is cos x dx actually. Cos x dx. Answer is sin x plus c. Moving on. Integral of sin x is given by minus cos x dx. Remember, derivative of cos is minus sin, right? But I have over here plus sin. It means it has to be minus sin cos x. Minus cos x actually. Please check. Okay. And 6 is done. 7th one, integral of tan. Okay. This is nothing but, okay, minus log in the mod cos x. Of course, I have made a mistake. This is not dx, right? This is simply plus c. Yeah. If you're not sure about the formula number 7, differentiate this. Log of cos x will become what? Will become minus 1 upon cos x, and derivative of cos as chain rule will give me minus sin x. Minus cancel. What is the answer? Tan. So the integration of tan is nothing but minus log cos x plus c. Minus log cos x plus c. Okay. These are the few. All right. Now, I'll give you a few more. I'll give you a couple of more, which is again important, but not, I think, not useful in the today's session. For example, this integration of 1 upon 1 plus x square is given as tan inverse of x plus c. Of course, you'll have a dx over here. Okay, a 1 upon 1 minus x square in the root is given as, with dx, sin inverse of x plus c. Okay, so these two are there. We also have few more formulas. We'll see that when I go to the particular functions. Okay, but right now your basic questions will revolve around these 7 formulas. Okay, of course there are a few more. We'll see that in the session itself, but these 7 formulas are a must. You cannot forget this. This has to be, like first step. You got to remember these 7 formulas. Okay, promise you have to remember all these 7 formulas. Very, very important. Extremely important. I know all of you must know this already. Okay, but let's continue. Next is what? Some properties of indefinite integrals. Some properties of indefinite integrals. Okay, so if there's a function defined like this, integration of a derivative function f dash of x dx is given by what? Of course, fx plus c. They are inverse of each other, right? Derivative and integral are inverse of each other. It means if you integrate the derivative, you'll get the function itself. integrate the derivative, you'll get the function itself. Okay, next, if you're integrating what, let's say two functions given in sum or difference, you can simply integrate them individually, then add it. Okay, basically you can separate the plus minus sign and integrate individually. Later you can bring it back as plus or minus sign. If you have a constant, you can keep it outside as k. Okay, if you have two functions in the given form of like this, d by dx of fx dx, okay, and we have gx dx, then what happens, these two functions will be equivalent in nature. Why not equal? Why not equal? Because of the constant. Because of the constant, we can't say just equal. Okay, maybe equal. So if you have derivative of a function given equals to derivative of another function, right, you don't be confused about the integral sign. Okay, they are saying that derivative of a function, let's say px, is equal to derivative of function, let's say qx, then you don't say that px and qx are equal. You can't say px equals to qx. Not always, dear. Not always. Think about it. If px was, let's say, excuse me, I'll write the functions. Example, x square and plus 5 x. Okay, over here I have x square plus 3x. Can they be equal? Differentiate this. We're gonna get over here 2x plus 5. This will be what? 2x plus 3. Of course not equal, right? So you can have a function which is not equal but might be equivalent in nature. Just an example I'm giving you. All right, great. Let me erase this. Already written over here. Let me erase all the markings on this particular screen. All right. So this is some properties. Your basic, very important property will be these two. These two are very important over here. Okay. When the integration is applied, you can separate that individual functions and then integrate, get back it with the plus or minus sign which is given to you in the question. Next is the keeping the constant part outside. These two are commonly used. We see that in the problems also. Okay, forgive me, I had to have some water. Let's solve this question now. Question number 1 from your integration chapter. 2 tan x minus 3 cot x the whole square. How do you solve it? Very simple question. Just you have a whole square, so apply that. You'll have here what? You'll have here 4 tan square x plus 9 cot square x minus 6. Sorry, not 6, actually 12. 2 into 3 into 2, right? It'll become 12 actually. 2 into 3, 2ab, right? So 2 into 3 into 2 will be 12 tan x and cot x. That's my whole thing, the whole expansion. And we'll see the integration part later. Right now let's simplify the given function to us. Okay, we'll see the integration later. Right now we'll go back and simplify the given function. Okay, tan square is nothing but 4 times of sec square x and minus 1, correct? Sec square minus 1. Same way, cot square is 9 times of cosec square x minus 1. Okay, and this is what? Minus 12x, right? Minus 12 into tan into cot will be cancelled, right? Minus 12. That's it. Simplify now. I'm getting 4 sec square of x. Yeah, 4 sec square of x minus 4 plus 9 cosec square of x minus 9 minus 12. Okay. All right, 9 plus 4 is 13. It'll become what? It'll become minus 25. So we'll write here like this: 4 sec square x plus 9 cosec square x and minus 25. This whole thing integral with what variable? With the variable dx. With the variable dx. Okay. I told you, if you have integral of sum of the functions or difference of the function given to you, take them individually and then take the sum and difference. Take for this term first, you'll have 4 sec square. Okay, I forgot to give you this formula actually. Yeah, I forgot to give you this formula. This is very important. Integration of sec square x is nothing but tan x plus c. This is sec square x dx, of course. And one more is there. Integration of cosec square x dx is given by minus cot x plus c. Okay, so I forgot to write these two formulas. Please write it over here, 8th and 9th. Sec square x dx and cosec square x dx. Okay, my bad, I forgot, but I've written over here now. Great, I hope you all know this anyway. Let's solve this question now. We can apply these formulas. Sec square x will become what? It will become simply 4 tan x. This will be what? Minus 9 cot x, and over here we'll have minus 25x plus c. A constant of integration. That's my final answer. That's my final answer. Let's see. Okay, let's move on then. Let's move on to next question. This is question number 1. Okay, question number 2 now. All right, guys, please cross check also. If I've made any mistake in sign or something, you have to let me know. Okay, if I made any mistake in the calculation or sign part, you have to let me know in the comment section. Question number 2 now. 3 sin x minus 2 cos x plus 4 sec square x. This simple question. 3 sin x, 3 will remain as it is. Sin will become what? Minus cos, right? So minus cos x. Okay, and minus 2 cos x will become simply minus 2 sin x. Integration of cos will be simply sin. Okay, plus it'll be what? It'll be 4 tan x. For sec square we have tan, and for this we'll have minus 5 times of cosec square will become minus cot x plus c is the constant of integration. Simplifying this step, I'll get minus 3 cos x minus 2 sin x plus 4 tan x plus 5 cot x plus c. That's my final answer. Please cross check. Okay, simply I've taken these 2 questions to help you understand how to apply the formulas. Okay, they are not going to be coming for your boards. Maybe they can come for MCQs, but will not be a board question. This is a very, very simple question, right? Simple formula based questions. Maybe board can ask it, but not KCET. But I've taken this question anyway because I want you to get used to the formulas, how we are applying it. Okay, question number 3 now. Now this is a good question. This is a very good question. How do you solve this? Please check. We have to look for what we can get cancelled and how can we use the formulas. Right now, if you see, very challenging. But if I break it down, if I break this question down, please check. Integration, I'll separate this term over here. I'll get 2 plus x divided by x square, 2 plus x, excuse me, 2 plus x, right? Not 2 into. Next we have the other term which is plus x square, but we get x square 2 plus x. Okay, this also is under integration. And the last one is what? The last one, again I'm going to write this as plus integral of 2x minus 2, sorry, plus 2 minus 2 minus 1 divided by x plus 1 the whole square. Okay, we have dx everywhere. I hope you know that. We have dx everywhere. Okay, so what I've done in the last step, I've added 2 over here. I removed that as well. Why I've done that? Because I can take x, I can take 2 common, it will become x plus 1. Same thing I have in the denominator. Okay, superb. Check this out now. 2 plus x is cancelled, x square is cancelled. The step is now simplified as integration of dx upon x square plus integration of dx upon 2 plus x, and this part I can separate it over here. I get plus 2 times is common, x plus 1 the whole square, of course, with dx, and the last term is minus 2 minus 1, which is what? Minus 3 upon x plus 1 the whole square, again dx. Let's see what I am getting now. The last step, let's do the integrations. Okay, of course this is cancelled, this and this is cancelled, one of this extra. Okay, this is nothing but 1 upon x square, so it will become what? Minus 1 upon x. Remember, whenever we have this thing, it's nothing but x power minus 2, right? Integrate this, you will have x power minus 2 plus 1 divided by minus 2 plus 1. That is nothing but x power minus 1 by minus 1. How much is that? Minus 1 upon x. Okay, this thing becomes here minus 1 upon x. All right, correct. I have 1 by x square, it becomes minus 1 upon x. This will be what? This will be plus log of 2 plus x. This part, log of 2 plus x. Superb. What about this? Plus 2 log of x plus 1. Because only x plus 1 is left over here, 2 is a constant, can be kept outside. And what about this? Plus 3 times of x plus 1 the power only 1 as the constant of integration as c. Please check. Right? Same. This also has the same approach that I've taken over here. The same approach. Okay? Instead of writing it as x, I can write this as x plus 1 the power minus 2 and use the same steps to get the result as minus 3 upon x plus 1. There is another minus over here that will make it positive. That's why we have plus 3 upon x plus 1. Good question. Okay, superb. All right. Let me know if you all understood question number 3. 3 is okay. 3 is clear. Superb. Question number 4 now. This is a simple question. Just one step. If you can visualize that one step, your answer is very much clear. It's a formula based question in that case. Have a look. E power x is there. Log is there. Log of a. And we have multiplied this with e power x. Okay. This whole thing with e power x is multiplied to this. Check. If I take this x over here, I can do that. Remember this property of log m power n. N comes over here, or I can take this back also. So I'm taking this back x over here. So it becomes e power log of a power x, the whole thing multiplied with e power x. We all know e and log are invertible functions. They are inverse of each other. E and log are invertible and inverse of each other. It means e on log or log of e is always 1. Okay, so this will be cancelled. E power log will be cancelled. I have only over here as a power x times e power x. What I get for this? A e power x. So basically a question is given in this format. Integration of a e power x dx. What is the answer for this? It's a formula. Remember, a e power x by ln of a e. Of course plus c will be there. A e power x upon ln of a e. Option is B. Question number 4, option B is correct. Over here in your syllabus, whether it is PU2 or CET, they mention log but they mean ln only. Okay, if nothing is written over here, it means the base is e itself always. Okay, that's why I've taken here ln directly. Got it? So in your syllabus, understood that log and ln is exactly same, but they are not. Log means with the base 10, ln means with the base e. But in this case, in your syllabus, always if nothing is written means log with the base e is written. Okay, clearly. Question number 4, option B is right. Question number 5 now. I think you all can give me answer. If it was a live session, I would have asked you to solve it. Okay, but it's not live, so I have to solve anyway. Let's solve it. We get 2x by 5 power x plus 3 power x by 5 power x. This thing becomes 2 by 5 power x plus 3 by 5 power x. Antiderivative means what? Integration. So integrate both of these. What do you get for this? 2 by 5 power x, and the same thing comes in the log. So log of 2 by 3. Sorry, 2 by 5, right? 2 by 5. Option C is correct. Please check. Remember this formula. Integration of a power x dx. Sorry, it's wrong. A power x, not a into x. A power x dx. A power x dx. This integration is nothing but a power x ln of a plus c. So that's why answer is this. Of course plus c will be there, right? Plus c is there. Option C is the right answer. 2 power 5 power x, 3 power 5 power x, and of course ln log of 2 by 5 and log of 3 by 5. Clear? 5th is clear? Okay. Question number 6 now. Derivative of a function is given as this. We all know that. What is this function over here? We all know the function is actually tan inverse. Remember, derivative of tan inverse is what? Derivative of tan inverse is 1 upon 1 plus x square. If you have forgotten, you can write over here 1 upon 1 plus x square is the derivative of tan inverse. Derivative of tan inverse is 1 upon 1 plus x square. Now what are they asking? They are asking us to find the derivative of this thing. Okay, please check derivative. What is this function going to be? F of x cube. In the function, replace this x by x cube. So tan inverse of x cube. It's not tan inverse the whole. No, it's only on the x. Please check. Cube is only on the x. Okay. Differentiate this. You're going to have tan inverse derivative will be 1 upon 1 plus whatever the value given over here. Whatever is the value over here, square of that. Right? Square of that. Square of that. What is the next step? Chain rule. Differentiate this function itself. You get here 3x square. What is my answer? 3x square divided by 1 plus x power 6. Option B is correct. Cross check. Have a look. Simple. Very simple question. Question number 6 is done, guys. Okay. If you have any doubt, if I'm going a little faster, whatever it is, you have to let me know in the comment section, okay? I'm going to change that aspect. Question number 7 now. 6th is option B. 7th. 1 plus 2 sin x upon cos square x. How do you solve this question? Very simple. You have cos square over here. You have cos square over here. Divide it to the numerator. Separate the terms for the plus sign. You get here 1 by cos square x. 2 sin x by cos square x. This becomes what? Sec x. Sorry, sec square x. And this becomes 2 sin x by cos x into 1 by cos x, right? Because you have cos square, no? I've written like this. Check this out. You have here sec square x plus 2 tan x into sec x. Tan x into sec x. Okay. I forgot to give you this formula also. I'll give you right now. Okay. This is what this formula is going to be. This formula is going to be what? Please check. Yeah. This part is going to be what? Simply tan x. This part becomes sec x actually. Sec x. That's your answer. Of course, plus c will come. 2 sec x. No, there's a constant 2 over here. So 2 sec x. So your answer is tan x plus 2 sec x plus c. Very, very simple question, guys. 1 second. Yeah. Plus 2 sec x plus c. Answer is tan x plus 2 sec x plus c. Option C is correct, right? Please check. So I forgot to give you this formula. I'll write over here. Forgive me, my bad. Yeah. 2 more important formulas. Formula number 10. Integration of sec x tan x dx is nothing but sec x plus c. Integration of cosec x and cot x dx is nothing but minus cosec x plus c. Okay. The last two. Sec x tan x dx is nothing but sec x integration, and cosec x cot x is nothing but cosec x with a minus sign. So minus cosec x plus c. Please have a look. Okay. Clear? Alright. My bad. I forgot to give you this. 5th is done. 6th is done. 7th also is done, right? Question number 7 also is done. Clear? Option number C is the right answer. Question number 8 now. Sin 2x minus 4 e power 3x. Very simple. We have to apply for one trigonometric function, other for exponential function. Okay, let's do it. Alright. So, whenever you have this integration of sin x, what's the answer going to be? Minus cos x. But if you have integration of sin ax, okay, of course there's a dx over here. Answer becomes minus cos ax divided by a. If you have a constant multiplied to the variable, check this out. 2 is multiplied. Here we have 3 multiplied. Whenever you have that in the given function, whether it is logarithmic function, whether it is exponential function, whether trigonometric function, whatever it is given, if you have a constant multiplied, okay, ax, whatever it is, you divide by that value. So it becomes minus divided by a. Okay, minus cos x divided by a. Over here, please check. So you can write here sin 2x dx integration minus integration of 4 is outside, so minus 4 is outside e power 3x dx, right? E power 3x dx. Alright, this 4 is outside. This 4 over here is outside. 1 second. Now if you integrate this, what is my answer going to be? Same rule. Sin 2x will become minus cos 2x. But is it over? No, divide by 2. You get over here 2. And for this minus 4 is a constant outside. Integration of e power 3x will become e power 3x, but the 3 is multiplied to the variable, so divide by 3. Whenever you have a constant multiplied to a variable in the given function, whether it is exponential, trigonometric, whatever it is given, logarithmic also, divide by that constant. Answer will be minus 4 by 3 e power 3x and minus 1 by 2 cos 2x. C. Question number 8, option C is the right one. Please check. Superb question. Do not forget. That's the formula, okay? Alright. So question number 8 is done. Question number 9 now. Okay. E power x log a log x and e power a log a. This is a constant anyway. We all know that. We'll use everything like this. A comes over here, this a comes over here, and this x comes over here. Check this out. So we'll have this function integration e power log a power x plus e power log x power a, over here e power log a power a, all with dx of course, all with dx of course. What we get over here, we get a power x plus x power a and a power a, this whole thing with dx. I'm looking for this integration. What I get, this becomes a power x ln a. Over here I have x power a plus 1 divided by a plus 1, and this will be what? The constant will be as it is. Nothing is there means you'll have x over here plus c. That's the final answer. Right? If you have nothing left over here, okay, what is this? It's simply a constant. If you integrate with the variable x, only the variable x will appear, correct? And of course plus c will be there as a constant of integration. That's your answer. So your answer is option A, I guess. A power x log a. Yeah, option A is correct. Question number 9, option A is correct. Please have a look. Simple question, just formula use. Okay. Now question number 10. Same approach, sec square of 7 minus 4x. How are you going to integrate this? Sec square becomes what? Tan of the same thing. But I've taught you this right now. If you have a constant multiplied to the variable, is it multiplied? Yes, minus 4. Divide by that. Plus c. That's your answer. Minus 1 by 4 tan of 7 minus 4x plus c. Option A is correct. See? So the question was taken just for one reason, that if you have a constant multiplied to any of the variables, okay, so in the variables, so any of the functions, whether it is trigonometric function, logarithmic function or exponential function, you got to divide by that constant, which is in this particular case minus 4. Your answer is minus 1 by 4 tan of 7 minus 4x. Don't write this as something different, okay? Don't write this as 4x minus 7 and all. It's not required. Okay, this, if you want to write this, no, I can take this minus sign inside, it will become 4x minus 7. If I want to take the minus sign inside, it will become 4x minus 7, not 7 minus 4x, right? Tan of minus x is what? It's minus tan x, no? So if I want my option to be option B, it should have been 4x minus 7, not 7 minus 4x. Please check. Okay, so correct answer is option A. Done. Let's move on then. Okay, so next up we are moving to MOI, method of integration. Alright, so as I said, we have multiple methods to discuss, but today's session will be only focused on the method of substitution. Because in some problems what happens, no, direct formulas that you have learned, right, I've shown you some 11-12 formulas, directly they will not be applicable. So you have to like use some different path. You have to go a little bit, you have to bend your way to approach the answer, and those methods are called as integration by the help of substitutions, integration using partial fractions, and integration by parts. So these are the three major methods that we're going to solve questions on integration by using them. Okay, of course, this being the, I can say, if I have to choose the priority level, highest priority will be given to the substitution method. Okay, substitution method will be having the highest priority. Second goes to by parts. Okay, and of course this will be the last. Partial fraction will be the last priority. Of course, when I say priority, what I mean by that, so basically if you talk about exam point of view, okay, if you bring in the examination point of view and you are talking with respect to whether it is PU2 or KCET, then yes, most of the questions of integration, let's say in case a total of 7 questions can come. 7 questions of the can be asked in just integration chapter. Okay, now from there 3-4 questions can actually be used on the basis of substitution. Next we can again expect 1 or 2 questions in the by parts as well, and so on. And there have 1 question max to max in the case of partial fraction. That's why I said priority will be given to the method substitution. Let's move on then. Okay, let's learn it. Now when do we use Okay, sir, fine, understood. Substitution method is the highest priority method to solve integration, to solve any question given in the integration. Now, when do we choose this method? How do we get to know whether in the question given to us that we should be going with this method only? Now, the answer for that question, if you're asking me, will be if you can find the, please listen to me, if you can find the derivative of the given function, of any function present in the given integration. Means, let's say integration is given like this, and you can actually see that there is a derivative. For example, I can say cos t. Cos t is there, but you also have sin t. Sin t, cos t, both is there. Okay, what is my answer? Simply take sin t as my function, because sin t derivative is nothing but cos t. Okay, so basically whenever a question of integration, a problem on integration has derivative of a function present, then we're gonna call what? Then we're gonna call that function to be, we're gonna substitute that function as our substitution of basically here in this case t dt, because this cos t dt now becomes, let's say I'm talking with respect to another variable, right? I have made a mistake, let me change that. It's going to be cos x, okay, x cos x, sorry, x dx, not cos x. I'm taking this sin t as a variable x, so cos x dx, cos t dt becomes your dx. Please check, differentiate this, you'll have this as please check, cos t dt by dx equals to 1. Bring on this side, you get cos t dt equals to dx. I've used that over here, please check. Okay, it's now x dx. Clear? So your question was, when are we going to use the method substitution? Answer is very simple. Whenever you can find the derivative present in the question itself, in the integral itself, then you can simply call that to be your what? Your substitution, the function to be substituted like that. Moving on. Some examples, whenever you can see here, ax plus b. Sir, where is the derivative? Ax plus b. Where's the derivative? I understand there is no derivative, but I can differentiate this. If I take ax plus b as t, differentiate it, you'll have a equals to dt by dx, right? So I can write this as, I can write this value basically dx as dt by a, no? I can bring this a on this side, dt by a. So basically this whole thing becomes what? F of t dt, and 1 by a can be constant taken outside. 1 by a can be a constant taken outside. Okay, so whenever, if you see here in this case, phi x has a derivative over here, phi dash of x is there, right? So basically this phi dash of x times dx will become what? Will become the dt value. I'll show you. Differentiate this, you'll have phi dash of x, okay, dx equals to dt. So if you substitute this over here, this part will become what? Integral of f t and simply dt. So this whole thing becomes this simplified fashion of integration. Got it? Simply just look for the derivative part and your question is solved like that. Okay, in this case your fx has a derivative in it. I'll show you this part as well. Differentiate this, you'll get f dash of x dx equals to dt. F dash of x dx equals to dt. That's my derivative form from here. Okay, now I'm going to use it over here. Have a look. So t value is fx, so it will become t power n, and this will become what? Simply dt. Simply dt. So is this simpler or this simpler? Which is simple to solve, this one or this one? Of course this one, right? That's why we do our substitution, because to make the question more relatable, more easier for calculations and simplification, right? So this is the method of substitution, how we use it, and some forms I want to discuss with all of you. Let's move on. Some standard integration for trigonometric functions, very useful. I think I already gave you this one. Yeah, for that I remember giving you minus log of cos x, right? I gave you this formula actually. It's okay, if you want you can take this minus sign over here. It becomes what? Log of cos of x power minus 1. This will become what? 1 by cos. How much is that? Log sec. Right? Yes, please check. So integral of tan x is nothing but log sec x, or in another way minus log cos x. You can choose either of them. Okay, next what? Integral of cot is log sin x. If you want you can differentiate the right hand side and get the answer. It will come as cot x only. What about sec x? Answer is log of sec x plus tan x. Log of sec x plus tan x. Okay, don't be confused, this is different formula. Log integration of sec x into tan x was there. Okay, if you are confused with this one, Answer for this is sec x plus c. Two different formulas. Integration of sec x into tan x is sec x plus c. But integration of simply sec x is what? Log sec x plus c plus tan x plus c. Okay. What about cosec x, sir? It is log of cosec x minus cot x plus c. But I'll tell you what, in the fourth one, this formula, we have another form which is very useful. You can see in the PYQs also, they have used this a lot. Okay. So I'll give you the other form also. See, can you see here? I've written. There's another form which is what? I'll explain it to you. Don't worry. So we're gonna substitute this in the form of a, which is a ratio tan theta. Okay. We'll check. We'll see log of right cosec. I'm giving you another form for the fourth formula. It's useful because in the PYQs it keeps coming up. Okay, so please pay attention. Cosec x is what? 1 by sin x. Okay, what is cot x? Cos x by sin x. Cos x by sin x. All right. Now if you take LCM, what's the LCM here? Sin x. Please check 1 minus cos x. Now we can use the formulas that we have learned in trigonometric functions. All right. Log 1 minus cos x is what? 2 sin square x by 2. Okay. And over here we'll have what? Sin x will be 2 sin x by 2 cos x by 2. We all know this formula. Sin x formula, the half angle formula. Okay. 2 and 2 is cancelled. This one of the sin is cancelled with the denominator. My answer becomes what? Excuse me, I have log over here. Only simply sin x by 2 by, I have only numerator, please check. Sin x by 2 divided by cos x by 2 becomes what? Tan x by 2. So answer becomes log of tan x by 2. This is integration constant plus c, so we can keep here plus c also. This is my second form of the integration of the variable or the function cosec x. Log of tan x by 2 plus c. All four are very important formulas. They'll be used. I told you I'm going to give you a few more formulas in the particular functions as well. That's there in the today's session itself. Okay. Some special substitutions. Some special substitutions comes to different forms. Please check. The first one is for whenever you have in the root a square minus x square. Whenever you have this in the root a square minus x square in the root, what are you going to do? Of course, take x as in terms of sine and cos. Why? If you take this as a sine theta, what happens to this? It will become a square minus a square sine square theta. You can take a square common, it will become 1 minus sine square theta. It will become what? A square into cos square theta. This is in the root, comes out as a cos theta. So you can easily get the root part substituted and done if you take the x substitution as a sine theta or a cos theta. Please check. A sine theta or a cos theta. Just to give you example, I have taken this explanation over here. Clear? Next we have a square plus x square. Of course, again we can use x as tan theta because 1 plus tan square is what? Sec square. Okay, so you can use a tan theta or a cot theta in the case of the form a square plus x square, whether it's in the root or without the root also. Okay, simple, easy enough. If we have x square minus a square, then we're gonna do what? Choose sec thetas. Choose sec thetas because the formula is sec square minus 1 is what? Tan square. Yes, you can put x as sec theta, it will become sec square minus 1. Superb. Same goes over here. A cosec theta also you can choose. Next, if you have a minus n, a plus x by form, you have a minus x n, a plus x form in the basically in the fraction form. Take x as a cos 2 theta. A cos 2 theta. Okay. In this case, x upon a minus x, we're gonna use over here a sine square theta. A will be not squared, only sine and cos will be squared. Okay. Do one thing, substitute, you'll get the result. Okay. Substitute this over here and simplify. All these, do it. They're very, very useful. Moving on. Do not worry if you are worried about that, sir, you just skipped it. It's okay. Do one thing. You have joined the class, the WhatsApp channel, right? Join the WhatsApp channel right now. Then only you're gonna get the class notes. I hope you have downloaded all the previous sessions class notes. This is one of the important chapter integration. I think I'm gonna do in 3-4 parts. So you have to download all these parts class notes, right? So please join the channel right now and subscribe the YouTube channel if you have not done till now. Because over here there are a lot of things planned to benefit you, whether it is for PU2, whether it is for KCET, everything is planned, whether it is for Comet K. A lot of things are coming which will help you achieve your dream college with the dream stream. Believe me, trust me, your seniors have done that. You can do the same thing. Just subscribe the channel and keep the notification on, and of course join the WhatsApp channel. If you do that, all the updates about the channel will be given in the WhatsApp group only, WhatsApp channel only. Okay, so join it right now for the class notes and for any update regarding our YouTube channel Diksha Karnataka. All right, now we have evaluate x times of 1 minus x the power 23. How are you going to solve this question? Please check. Do we use binomial theorem? Do we do the expansion of 1 minus x power 23? Of course not. If you do that, if you do the expansion of 1 minus x power 23, it takes so much of time. But if you use substitution, take 1 minus x as t. 1 minus x as t, excuse me. Okay. Then what happens is your x becomes, from here you check, you can bring this, it will become 1 by minus t equals to x. 1 minus t equals to x. Okay. So I have this and this sorted. What about dx? We'll do that as well. Differentiate this, you'll have minus dx equals to dt. You'll have minus dx equals to dt. 1 will be 0, x will become minus dx, okay? And this will be dt because dx comes over here, right? Actually x will be 1, but you'll have dt by dx over here, no? dx will go on that side. I hope all of you know that already. Okay, let's substitute it back now. The question is now, x becomes what? X becomes 1 minus t. And this becomes simply t power 23, and dx becomes minus dt from here. Now question is different, minus, we get expansion over here, t power 23 minus t power 24, correct? Of course we have dt now. Let's use this, let's change the order. We get here integration of t power 24 minus t power 23 dt. Because I've taken this minus sign inside, okay? That's why it's become t power 24 as positive. Last step, answer will be what? T power 25 by 25, okay? And over here, t power 24 by, what is it? 24 plus c. What's the t value? T value is 1 minus x. So put here 1 minus x power 25 upon 25 and 1 minus x power 24 upon 24 plus c is my final answer for this question that we solved using substitution method. That is solved using substitution method. Please check. Clear? Okay, 11th one is clear. Have a look. Let's move on then. Question number 12 now. Question number 12, it says cot x upon ln sin x, right? Cot x upon ln sin x. How do you solve this? Anyone who has solved any question of integration will know that, sir, ln sin x is my substitution. If not, think. Derivative of log. Look, the thing is, I told you how do we take substitution. Very simple. You have to look for the derivative. And derivative of log sin x is what? 1 by sin x for log, sir, and for sin x we have cos. It becomes cos by sin. It becomes cos by sin. Please check. Take ln sin x as my substitution, as t. Differentiate now. You'll have 1 by sin for the log part. 1 by sin over here. And what about sin? You'll have cos x. This will be dt by dx, right? Move this on this side. Cos by sin is what? Cot x dx equals to dt equals to dt equals to dt. Okay, have a look. I can see now question. Integration of dt numerator, cot x dx is dt upon, what is it? Simply t upon simply t. What is the answer for this? Of course, sir, ln t plus c. Log of t plus c is my answer. Substitute and put the value of the variable back. We get log of t value is log sin x. So put here ln sin x equal to t. Do we need to write this value? Please check, there's no option, right? So this is correct. So your answer is log of log sin x, sorry, y equal to, I wanted to erase this actually, it's not equal to, right? It is just simply plus c. Indefinite integral, so plus c. That's the final answer. Log of log sin x plus c. Okay, 12th is done. Question number 13 now. Problem number 13. Another beautiful question. It's a MCQ. Let's solve it. can be asked a similar question in your KCET or even the MCQ section of PU2, because it's not difficult. They can ask this kind of question. So we can see here we have e power minus x. Let's do one thing first. Before substitutions, we'll simplify this part. Before moving with the substitution, we'll simplify this part. E power x 1 upon e power x plus 2. This much is okay. We'll do the substitution now, sir. No, we'll not do the substitution right now. We're gonna do some more steps. We're gonna get over here as e power 2x plus 1 plus 2 e power x. We have the numerator over here as e power x dx integral. Please check. What I've done, I've taken this denominator e power x in the numerator now. Okay, so e power x dx I am getting. These are my two different steps. Next one. Alright, we'll keep here e power x dx as it is. Look at the denominator. We'll have e power x the whole square, 1 square. So I'm getting actually e power x plus 1 the whole square. E power x plus 1 the whole square. Next step is what? Next step is substitution. Next step is your substitution method. Okay. Take e power x plus 1 equals to t. And this whole thing becomes what? This whole thing becomes derivative I have to do to replace the dx part. Next step is to replace the dx from here because variable is changed now. Okay, so this will be e power x only, this will be 0. Dx I get dt by dx. Put on this side I get ex dx equals to dt. Substitute back. My question is changed now. I have here dt integration for the numerator. Have a look, this is dt and this is t square. Answer for this is minus 1 by t. Minus 1 by t. You all know that? Remember? That's the answer. Whenever we have t power minus 2, you have to integrate. It will become what? T power minus 1 divided by minus 1. That's why simply minus 1 by t plus c. What is t value? T value is e power x plus 1. That's my answer. Option B, minus 1 by t plus c. Option B is correct. Please check. Simple. Okay, simple. And but yeah, you have to do one step to get the substitution right. Okay, otherwise you'll be stuck. Next problem is question number 14. Now how do we solve this question? Sine 2x upon sine square plus, okay, I can see there's a sine square, there's a 2 cos square. I don't need that. Do I need that? No. Please check. 2 cos square x is there. I can take 1 cos square out with sine square, it will become 1. Okay, let's do it. Let us do it, so I get sine square x plus cos square x plus cos square x dx. Okay, expansion of sine 2x, there's a formula, we know that, right? 2 sin x cos x. Yes, 2 sin x cos x with dx divided by, what is this? 1 plus cos square x. Sine square plus cos square is 1, so 1 plus cos square x. Okay, that's all right, sir. That is acceptable. Superb. Now if I take this whole thing as my t, I can do that for the substitution part. For the substitution part, I can do 1 plus cos square x as t. Check this out. 1 plus cos square x equals to t. How can I say that, sir? Because of the practice that I've done, no, I can visualize from the one step before. You can also try. Differentiate 1, it will be 0. Cos square x, it will become, first derivative will be 2 cos x, right? So 2 cos x, and derivative of cos will be minus sine. Yes. So 0. We'll have 2 cos x over here, and you have minus sine x. This will be dt by dx. Look carefully. What I'm getting over here, same thing, 2 sin x cos x. Bring this side, we get 2 sin x cos x with dx equals to minus dt. How can, sir? How can you say that? Because I've moved this minus sign over here. So minus dt. Now this whole thing becomes what? This whole thing becomes integration of minus sine dt upon t. So ln minus ln t plus c is my final answer. So minus ln t is what? 1 plus cos square. So right here 1 plus cos square x plus c is my final result. C is my final result. Please check. Clear? Is that clear? Have a look. Okay. C is the final answer. Next one. Question number 15. Sorry, yeah. Question number 15. 1 minus tan x upon 1 plus tan x. Now you can see clearly in the questions given to you, options given to you, forgive me, they're everywhere cos and sine. Then what is the first step? Convert everything that is given to you in the question in terms of cos and sine. We can do that. We get here 1 minus sin x by cos x upon 1 plus sin x by cos x, and we have dx of course over here. LCM will give me cos x minus sin x upon cos x plus sin x dx. Clear? Have a look. If I write here, no, I'll get the cos x over here and over here as well. Both will be cancelled, right? Because they're in the denominator for both the sides. We can cancel that. Alright, superb. Next is what? Next is to substitute what? Have a look. If I take this part as my substitution, cos of x plus sin of x equals to t. Differentiate then. What I'm going to get? Cos x will be what? Minus sin x. And this will be what? Cos x. And we having here dt by dx. Bring it back on this side dx. I get cos x for second, right? Positive part minus sin x multiplied with dx equals to dt. And I can see that you have the same step over here. Cos x minus sin x times dx. Cos x minus sin x times dx. So replace this. What I get? Integration of dt by t, which is what? ln t, which is what? Of cos plus c, ln of cos plus sine, or sine plus cos, your choice to write. Final answer is log of sin x plus cos x plus c, the constant of integration. Option A is correct. Have a look. So questions are not that difficult. Of course, there might be 10% of question which is very much challenging. Yeah, in integration, there's some 10% of questions when it comes to definite integral that can challenge you. But apart from that, they're very, very simple. Have a look. Okay, 15th is done. Question number 15 is over. 16 now. Okay, if I'm going faster, let me know in the comment section. Sir, please slow down. This is an important chapter. Whatever is your feeling, let me know. And otherwise, I'll keep going at my pace. Okay. If I'm going slower, let me know that as well. Sir, it's increase the speed, but I don't think that will be the case. Yeah. Question number 16, how do we solve it, sir? ln x we have by x. So this is a very simple question, right? Yeah. This ln x is my so the substitution in this case, because if I take ln x equals to t, then differentiate this. We'll have 1 by x equals to dt by dx. From here I have what? I have 1 by x dx as dt. The same thing is over here. Please cross check. This becomes t power n, and this whole thing is nothing but what? dt. So dt answer will become t power n plus 1 divided by n plus 1 plus c. That's my final answer. T is ln, so check this out. Option A is correct. ln x upon n plus 1 divided by n plus 1 plus c. Option A is correct. Have a look. Option A is the correct option. Alright. Simple. Question number 17 now. E power x 1 plus x is there, and we have sine of x e power x dx. Look for the answer for this. Same approach. Okay. Same approach. We can take x e power x equals to t in this case, because if you do this, no, you'll get this whole numerator as the dat part, whole numerator as the dt part. Check this out. Keeping x as it is, we get e power x. Keeping e power x as it is, differentiate x, we get 1 equals to dt by dx. Take e power x common, we get x plus 1 dt. Bring dx over here as well. Have a look. This question becomes dt upon sin t. dt upon sin t. What is that? Cosec t dt. Cosec t dt. I just wrote the formula for this. Remember? It was nothing but log of tan t by 2 plus c. Log of tan t by 2 plus c. Okay? That's your option. Option B then. Please check. T you can write, no? T is xex by 2. So I get xex by 2. Answer is log of tan t by 2 plus c. Log of tan t by 2 plus c. 17th is done. Question number, so okay, we have to move on to 18th as well. But before that, one last topic to cover today, which is integrals of some partial fractions. Okay, again, so you don't have to worry about derivations over here. Not because we can't do it, because it is not required. Okay, if you remember the formulas, I think there are some 10 odd formulas. Yes, there are 10 odd formulas. If you remember all the 10 formulas, then direct question can be applied in the examination, direct questions. Okay, and they do ask that when we go ahead and see our PYQ sessions, whether it is for PU2 or KCET, we find it out that yes, a question is rightly given on the particular functions. We'll check this out. First one is integration of whenever we have x square minus a square over here in the denominator, without root x square minus a square. In that case, what happens? You'll have log function. You have log function. You have 1 by 2a as the coefficient. You have log of x minus a upon x plus a. What about if this is a square minus x square? What about this is a square minus x square? 1 by 2a will remain as it is, and what will happen to the this thing? A minus x will come in the denominator. This a minus x will come in the denominator of the log. So that's how you remember the pattern in this case. If it is x square minus a square, x minus a comes in the numerator. But if it is a minus x, so if you have a square minus x square, then a minus x comes in the denominator. Okay. Now, if you have a square plus x square, then this becomes a tan inverse problem. How come, sir? Please check. In this question, if I take a value as 1, then this becomes what? 1 upon 1 plus x square. What is the answer for this? Tan inverse of x, right? So whenever you have a square plus x square without root, of course, it becomes a tan inverse. So if you have negative signs, it will be a log answer. You'll have log on both sides, and there will be a coefficient of 1 by 2a, 1 by 2a. In case of tan inverse, you'll have a coefficient of 1 by a. 1 by a. And how to take the sign? If it is x square minus a square, you get x minus a in the numerator of the log, and if you have a square minus x square, it becomes a minus x in the denominator. This is the way I remember it. This is the way I want you to remember as well. Simple way to understand. Okay. All right. Next up, a few more particular functions when you have the same formula x square minus a square, but with a root this time. With a root this time. Again, log will come. X plus the same root will repeat over here. Same root will repeat over here. If you have a square minus x square, what will happen to this? This will become a sine inverse formula. Please remember, if I take a value as, if I take over here a value as 1, what will this become? It will become 1 upon root of 1 minus x square dx. Correct? So this will become what? Formula for sine inverse of x. Same thing is there. So if you have 1 upon root of a square minus x square, there is no coefficient, simply it is going to be sine inverse of x by a plus c. If it is plus, you'll have log of x plus, same formula. Just in this case we have plus sign, so the same root will come over here. These two are same formulas. Okay. Now the last three. I'll tell you an interesting part about the last three formulas. There has been a lot of questions. I'll show you in my coming sessions. I think I have one in today's session also. I'll show you that as well. So there is a question. If you can just form this left side, and just one step required to do that, you get the right answer as one of the options. Means one step question. So very difficult formula to remember, but that is it. If you know that, there is no way to apply it. Just if you know the formulas, that's your answer. You don't have to do a lot of steps in this. Okay, please check this out. Root of a square minus x square if you are looking for integral in the numerator, there is no denominator over here. There is no denominator. Answer will be what? X by 2. Same root will repeat. X by 2, same root repeats. Okay, and then we have a square by 2. We have a square by 2 if it is, and then it is the same form, a square minus x square. A square minus x square, so we'll have sine inverse over here. Other cases, if you have a square plus x square, what will happen? X by 2, same root will repeat. A square by 2, log will come with the same root. Okay, if in this case x square minus a square dx is there, x by 2, same root will repeat. Again, we'll have a minus a square by 2 in this case, and log of x plus x square minus a square. Okay, so there's similarity in the formulas. If you remember one of them, you can recall the other ones just with the logic. Okay, chali. Now some more types of particular function. This is from NCERT. I hope you remember that. If you have this form, quadratic form over here in the root or without the root, how do you solve this kind of question? Basically, you have to make this into the whole squares, a perfect square to make. You have to make here perfect squares. You need to make here perfect squares. What is required to do that? Do it, and once you do that, you can use one of the particular function, whether it is this form, this form, this form. You have to check this out, okay, or this form, because it can be either the first three form or it can be either this three form, right? You will not have these cases, right? Please check. Will you have? No, because this quadratic form is there in the denominator, okay? That is there in the first three forms over here and first three forms over there. So it can be either of the form based upon whether it is a root question or not, okay? What is the step to do this question? First step is to make a perfect square in the given quadratic and check which is the suitable formula. Based upon the formula, you have to give the answer, okay? There are total of 9 formulas, 6 here and 3 here, so total of 9 formulas, okay? I'll erase this marking just to make things clearer for you. Once you download the class notes now, this should be clearer for you, okay? I'll erase these markings, all right? Okay, total of 9 formulas which are very, very important. Next one. So this is clear how to do this. Step number 1, make the coefficient of x square is unity. This should be always 1 actually, always 1. And express the resulting expression as a perfect square. Unity, perfect square. Okay, and then last is use the suitable formula to evaluate your given integral of the particular function. Next is what? The special case, again from NCERT, if you have linear form in the numerator and quadratic in the denominator, with or without the root. Without the root, with the root. Then what? Then this is the form. You're going to equate the numerator, which is given to you, px plus q, as a times of d by dx, as a times of derivative of denominator. So basically compare the numerator that is given to you, whether it is this form or this form doesn't matter. Whether it is with or without the root doesn't matter. Both the cases will have same applications. Just take this part, put it here, and differentiate the denominator, okay, and in this format, a times a constant a times of this plus b. Compare to find the value of a and b. You can find the value of a and b from here, right? Comparison. This will be the same form, px plus q. You'll have a linear form. One as the coefficient of x, one as the constant term. So compare to get the value of a and b, okay? And once you get that, you put it back in the equation in this format only, and use the suitable formula to integrate and get the result, okay? Don't worry, we'll see the questions, we'll see the problems. This is clear, right? This is clear. Again, I'm going to repeat the steps. The steps are very simple. First step is to the numerator which is there, compare that with the derivative of denominator. Using that, you have this form a times of this plus b. Get the value of a and b from there, okay? And then later put it back in this expression and integrate this, okay? All right, you have to use the suitable particular function, of course, functions to get the final result. Let's move on. Okay, question number 18 now. Find the values of this x square minus 1 upon x square plus x square, x bar 4 plus x square plus 1, okay? X bar 4 is the problem, right? X square 4 is the problem, correct? Let's do one thing, divide by x square. To get 1 minus 1 by x square divided by x square plus 1 by x square, okay? X square plus 1 by x square, correct? All right, we can make a fraction over here. We can make something over here, right? We have a square, we have b square. Check this out. We have x square, we have 1 plus x square. What is missing? Plus 2 is missing. Why plus 2 is missing? Please check. If I do that, if I add plus 2 over here and remove plus 2 from this side, what we get? Combine these three terms. We get x plus 1 by x the whole square minus 2. Minus 2. Please check. Please check. I have here, I have taken these two terms only, x square plus 1 by x square term over here, added plus 2, remove plus 2. Plus 2 will make this x plus 1 by x the whole square. X square 1 by x square, 2 times of these two terms becomes simply 2. Clear? Okay. That's what I have over here. Now, if I differentiate this, if I take this as my substitution, what happens is, if I take this as t equals to x plus 1 by x, okay, derivative will become what, dear? It will become dt by dx equals to 1 minus 1 by x square, which is there over here. Please check. Correct? For this you'll have 1, for this you'll have minus 1 upon x square. Okay, superb. It means something is working out over here. Let's continue. I get this as 1 minus 1 upon x square dx, and for this what I have, I just did this x plus 1 by x the whole square we also have minus 2 and we have plus 1. So add plus 1. There's a plus 1, I've not changed that, okay? This plus 1 continues. This minus 2 comes from here. Have a look. So now what is this? I'm going to use the substitution. This will become simply dt. This whole thing will become, if I move this dx on this side, it will become whole thing as dt. And this will be t square minus 2 plus 1, simply minus 1. Okay? Minus 2 plus 1 is simply minus 1. I can write this as 1 square also. Now we can apply the formula for this. We can apply the formula for this. What is the formula? dt by t square minus 1, x square minus a square. Answer is 1 by 2a. A is in this case is 1. So I write this as 1 by 2 into 1. Excuse me, 1 by 2 into 1. And we have log x minus a upon x plus a. T minus 1 upon t plus 1. Okay? Plus c is there. I get 1 by 2. Of course, log is there. T is what? T is x plus 1 by x. So right here, x plus 1 by x minus 1 upon x plus 1 by x plus 1 plus c. Simplify this. I get 1 by 2 log. I get here x square plus 1 minus x divided by x, whole thing divided by, again same thing for the denominator also, x square plus 1 plus x. Okay, x square plus 1 plus x, in this case divided by x plus c. This is cancelled. My final answer is this only. Please check. 1 by 2 log of x square minus x plus 1 divided by x square plus x plus 1 plus c. That's my final answer. That's my final result. Please check. 1 by 2 log of x square minus x plus 1, x square plus x plus 1. No mistakes? No mistakes. Okay, superb. This is a working part, okay? This is all done for the substitution. All done for the substitution. 18th is done. 19th now. This is clear. Every step is clear. Have a look one more time. But do not worry, you can download the class notes and have a look again. Try to solve this question again. But have a look. 19th one. Sec x tan x 9 minus 16 sin tan square x. Okay, 9 minus 16 tan square x. Tan square can be written in terms of sec square. Okay, sec x tan x I have 9 minus 16 times of sec square x minus 1 dx is there. I have written tan square in terms of sec square. That is the simple thing. Next, sec x tan x by 9 minus 16 sec square x plus 16 dx. Minus 16 sec square x plus 16 dx. Okay. All right. We can bring this together. What I get for this? I get here 20. Okay. Excuse me. Sec x tan x. Of course, dx is there. This becomes 25 minus 16 sec square x. Okay. But I have to take this this whole term before, I have to remove the coefficient from here. I have to remove the coefficient from there. I should not have any coefficient. Only there should be a variable square. Okay. I can remove this 16 by taking common. Let's just do that. I have here sec x tan x dx. All right. And take this 16 common. It becomes 25 by 16 minus sec square x. Okay, this is clear. No problem whatsoever. Right? Correct? Okay, I've taken the 16 common because I could not have any coefficient for the variable x. In the formula, remember, a square minus x square, there was no coefficient of x. X was simply, the coefficient was simply 1. The coefficient was simply 1. Okay. Superb. Let's do, I can have to substitute over here sec of x. Okay. Sec of x. 1 second, guys. Sec of x as t. So derivative will be what? Sec of x tan x. Okay. Dx will be simply dt. I can write directly now. I hope you all get it. Okay. This whole thing is dt. So 1 by 16 is there. We have dt over here. We have 25 means 5 by 4 the whole square minus t square. Answer. Very simple. 1 by 16 as it is. 1 by 2a means 1 by 2 times of 5 by 4. 1 by 2a. What is this next time? Next is log. Then what? Then what? We have here a minus x will come over here, right? We'll have 5 by 4 minus t will come over here, and 5 by 4 plus t will come here with the plus c. With the plus c. Have a look. What do we get? 16 to 2 is 32. 4. So I can cancel this both with 8. Okay. My answer is coming like this. 1 by 8 5 is 40. So 1 by 40. And we have of course log. And this is nothing but t is sec x. So 5 plus 4 sec x, right? 1 second. So this is 5 plus 4 sec x divided by 5 minus 4 sec x plus c. That's my answer. Please check, guys. Last step, I hope this is clear. 5 by 4 plus t, right? T is what? Sec x. LCM if you take, it's going to become what? 5 plus 4 sec x divided by 4. 5 minus 4 sec x divided by 4. Those 4 cancels. That's my final answer. 5 plus 4 sec x, 5 minus 4 sec x plus c is the answer. 1 by 40 is correct, I think. I have 16 to 2 in the over here product, that is 32. 4 8 are 32. 8 into 5 is 40. Correct. That's my final answer. This is my answer. Please check. Problem is done. 19th problem is over. Now it's time to solve a homework. Okay, solve a homework. This is again similar question, remember? Let's bring the 9 outside because we have to make this x square coefficient free. Okay, this is your homework. Solve it, guys. Okay, that's your homework. Question number 20 is your homework. 21 now. Dx upon x square plus 8x plus 20. X square plus 8x plus 20. Whenever I told you this, I gave you a particular function form. We have to look for making the perfect square first. The first step was to look for the coefficient of x square as 1. Is there? There is no coefficient. It means 1. And what is the next step? Next step is to find the perfect square form. Okay. So I have x square plus 8x plus 20. I can see I have x square plus 2 times of x times of 4. 2ab is there, right? A square 2ab. What is b in this case? B is 4. Means 4 square I want. Remove 4 square from here plus 20. Correct? I have a square. I have 2ab. B is 4 in that case. 2 into x into 4 is 8. 4 square will become 16. Remove that also out. Okay? Now these 3 steps will become what? X plus 4 the whole square. X plus 4 the whole square. What is the next step? 20 minus 16, which is what? Plus 4. Now check this. Given integration to you is as, have a look, dx upon what we have? We have 4 plus x plus 4 the whole square. Okay, I can write this as dx upon 2 square plus x plus 4 the whole square. Remember, this is a form of tan inverse. 1 by a. 1 by a. What is a here? 2. 1 by a tan inverse of x by a. So x plus 4 by 2. Of course, plus c is there. 1 by a tan inverse of x plus 4 by 2. Correct. Option B is right, no? Have a look. Option B is the right choice. So only step was to get the perfect square right. Then formula is very simple for tan inverse, and answer is option number B. 21 is also done. Let's move on then. Question number 22. 7x plus 3, 3 plus 2x minus x square. How do you solve this question? Same thing. Try to use over here. What? Try to use over here the perfect square method. Okay. Then only one of the formula can fit in, right? All right. So I can see this x square is negative. Means I have to make some changes over here. Okay, I'll just go with this part. 3 plus 2x minus x square is there. I'm going to write this as 3 minus. I'm taking minus sign common. This becomes x square minus 2x. Correct? I've taken minus sign common. Alright. So I'm getting over here 3 minus. Have a look. I have x square. I have minus 2 times of x times of 1. What is missing? What's missing here? I have plus 1 missing. So add this plus 1. Can you add something like this? Of course not. You have to remove that also. So do it as minus 1 also. Do it as minus 1 as well. Please check this out. I'm getting 3 minus, I have a bracket, x square minus 2x plus 1. It becomes x minus 1 the whole square. And that minus 1 side is as it is. Okay. Let's continue. What I get for this? I get 3 minus x minus 1 the whole square plus 1, right? This minus sign comes out, becomes plus 1. Simply I can write this as 3 plus 1 as 4. So remove plus 1 from here and write this as 4. Write this as 4. Okay, now this integration becomes like this: 7x plus 3 divided by root of 2 square minus x minus 1 the square. X minus 1 the square. Correct? X minus 1 the square. Now if I take this as, if I take x minus 1 as what? As the substitution. X minus 1 equal to, let's say, t. Then what happens over here? I get this value of x as t plus 1. This whole thing becomes what? Please check. I have dx over here. This will become dx minus, basically 1 minus 0 equals to dx, dt by dx, right? 1 second, guys. I'm differentiating this. I get 1 equals to dt by dx. So basically dt and dx are same from here. This integration is changing now to 7 times of t plus 1 plus 3 divided by 2 square minus t square, of course dt. Have a look. 7t plus 7 into 1 is what? 7 plus 3, 10 divided by 2 square minus t square dt. Have a look. Okay, I'll write this step again next slide, but have a look. I'm writing this x value as t plus 1. How can I do that? By the help of my substitution. Okay, it becomes 7 times of t plus 1 is 7t plus 7. 7t plus 7 plus 3 is 7t plus 10. Okay, and this is as it is. So far I have 7t plus 10. This is a bracket, right? What is that root? I have 2 square minus t square. Here also 2 square minus t square. Root, this also is dt, and this also is, of course, dt. Both of these are dt only. Have a look. Right? Both of these are dt. This is simple. This is the simple formula of what? Sine inverse. This will become what? 10 times of sine inverse of what I get? Yeah. What is it? T by 2. T by 2. Correct? So I get 10 sine inverse of, what is t value? T value is x minus 1 by 2. 10 sine inverse of x minus 1 by 2 is one of the part. X minus 1 value is t. So 10 times of sine inverse of x minus 1 by 2 is one of the part. Means these two options are gone. These two options are gone. Okay. Now other option, please check. Just this part. Okay. What I have for this part? 7t upon root of 2 square minus t square. You can see clearly from here, I'm getting a plus sign, right? I'm getting a plus sign. So of course this minus sign cannot be there. Think logically. If you check over here, I'm getting a plus sign, right? This is plus sign. Even if you take this as the root inside, like basically this is going to become what? T power minus 1 by 2. If you add to this 1 by 2, if it was some other variable, let's say it is y. If you add 1 to this, what happens to this? It will become again 1 by 2. Getting my point? If I had 1 by y in the root, it becomes what? Y power 1 by 2. It becomes what? Y power minus 1 by 2. If you integrate, you'll have to add 1 over here. It'll come out as what? It'll come out as y power 1 by 2. It will basically come out as root y. So my whole point is that if you integrate this form, you'll have a positive sign. You'll not have a negative sign. Okay. So let me erase all of this. Okay. And please check first. This is a positive sign, means option C is the right choice. Option C is the right choice. Of course, this is the same root. Why I'm not doing this, all of this? Why I'm not doing the second part? We don't have to, because you can see they are the same root. Okay. Just figure out the sign part. Please check. 1 second. I'll explain again if you are confused. No problem. No problem. Okay. So basically I'm trying to say that do not worry about the integration of the second part. No need to do the integration of the second part, because everywhere it is the same thing. Please check. First of all, we don't have to worry about option A and B, because option A and B is wrong. Option C and D is one of them is correct option. Okay. Now this is same. 7 coefficient is also same. Of course, we are also getting 7 here. You are also getting 7 here. Then why we are not worried about this integration? Because we have to look for the sign over here. Even whatever it is, whatever is this, let's call this to be variable y. Integration of 1 by root y is what? Is root y. Of course, by 1 by 2 will come. Yeah, that's it. So that part will be counted with the help of t, don't worry. Okay, so basically my sign is what I need. Sign is going to be positive. Is it there or not? Yes. So plus sign is there in only on option. Option C. Option C is the right choice. Option C is the right choice for this question. Okay, option C is the right choice for this question. All right, so this all is not required, sir. No need to do the second part, only the first part gives me the answer and understanding of the sign of the second part. Okay, got it? Try once from your side. If you want me to, let me know in the comment section. I'll come back and solve this question again in one of the sessions. Okay, I'll solve this, no problem. But I hope this is clear now, how to pick the right choice. 22 is done. Next question. Because this is an MCQ, right? You're supposed to be fast in your method. How can I do that? By eliminating the wrong options. Okay, now this is your homework. This is your homework. I have given you one homework so far. This is my second one. I'm going to give you one more, which is 24th question. Also your homework. Again, a particular function. Remember, you're going to make a whole square over here with the help of x square and minus 7x. Take minus sign common with these two terms. Okay, all right. Please solve this. So question 24 and 23 is your homework. Okay, this is simple, right? You can take e power 2x common, do it, or multiply e power x, do it. It's a simple question. Solve this. 23 and 24, the total of 3 homeworks given to you, and that is end for the session today. All right, so I planned to give you more than 3 homeworks actually, but it's okay. I solved more questions. So total of, we have covered total 24 problems from the topics. What are the topics? Substitution method, particular functions, and of course your indefinite integral introduction, the formulas, different functions. We have covered all of that. Total 24 questions, 3 is given as homework. So you have to cover up, you have to solve those 3. How can I do that? Download the class notes from the WhatsApp channel and solve these questions that I've already solved and solve the homework that I've given to you. Let me know in the comment section that you got it right. Okay, if you did not get it right, if you have a doubt, you can ask me. If I can clear over there, I'll clear. If not, I will come back and solve in one of my sessions. Okay, so this completes our session today. I hope you had fun. I had fun teaching you. One of my favorite chapters is integration, so I was very excited to start this, and we'll come very quickly complete this session. I think we'll try to complete it in 3-4 parts with one of the KCET PYQs. Once we are done, we'll let you know. You let me know how was it, how did you feel solving the problems. So that is for today. I want to see you again very soon. Till then, take care. Bye bye.